And next part of the lecture is devoted to the surface water flooding. And there are two types of surface water flooding. It's pluvial flooding. It is the surface water flooding which is caused to when the volume of rainwater falling does not drain away through the existing drainage system or soak in the ground. And we have also surface water fluvial flooding, which is the another type. And the main difference is lies in the next. Then the water level of the river or lake or stream rises and overflows onto the surrounding banks, shores or neighboring land. And here is the photo of the fluvial variant of the surface water flooding. So next kind of situation which we will consider, it's when we are working with the surface water flooding and the construction sites which are located in the locations which are potentially can be related to the surface water flooding. We have to make preventive measures. So first of all, it is in the artificial increasing of planning marks of the territory surface. So locate your building as high as it possible. You have to bring additional sand or other kind of soil to locate it on the surface to make the position of your building as high as it possible. So it will protect your building from the future increase of the level of the water. It will be something like Venetia or Ukrainian Venetia, which is located in on the south of our region. It's Ismail region, but I forgot how that small city called. Uh, Venice, like Ukrainian Venice. Sorry. Protection of territories from flooding should be carried out by embankment of territories from the river, artificial increase of the relief, and accumulation, regulation, and drainage of the water. So next difficult ground condition which we will discuss called sinkholes. And sinkholes is a huge problem of our territories because sinkholes can lead to the certain emptiness or holes on the ground under our building. So, and there are two types of sinkholes. They called karst and submersion. So karst is a complex geological process. It is a process of dissolution of soluble rocks, and it can lead to such kind of emptiness under ground or caves or sinkholes. So this is the first difficult ground condition which we are discussing. Next, called submersion. So the main difference between karst and submersion is lies in that when we consider the situation of the karst, it is a process of dissolution. So in the case of submersion, it is the process of the when the underground water flow transport the small particles of soils between the big particle between the large particles of soils, which leads to such situation. And then this soil makes such kind of cave above or underground, which leads to the certain problems to the buildings which are located above or not from such construction sites. And we have next classification according to Ukrainian building codes or the sinkholes, and here are they are. So we have six main categories of sinkholes for car sinkholes, and the worst case scenario it's is the first category with one sinkhole, one karst sinkhole on square kilometer per year. When we are considering the next kind of classification, this kind of classification is related to the size of the sinkholes, of the karst sinkholes, and the worst case scenario is when we have the biggest according to this classification, a size of sinkholes, it's more than 20 meters. So you have to know that the first category and category A are the worst for the sinkholes when we are considering these difficult ground conditions. And a few more questions connected with the submersion. Here is the impact of the underground water on the creation of such kind of caves, and we have to use planning measures so not to collect the water in certain places of the ground, so it's to protect them from carst and submersion. Waterproof and anti-filtration, geotechnical solution, constructive structural solutions, technological and operational. So it's due to the good monitoring of the underground waters, we can also protect our building from karst and submersion. Next, it is all those solutions that I've told previously in details. I will not stop on that. Next, the question that we will discuss today, it's abrasion. It's a coastal abrasion. It is destruction of the coast soils with the strikes or kicks of the waves or on the seashore. So, and here you can find the result of such abrasion on this line. So, and we have certain actions against abrasion, so we can protect our seaside seashore from the abrasion. It's wave protection. It's dumping wave of wave energy. It is beach restraints, which serve to protect the seashores from the kicks of waves. Next solution, it is a landslide and very widespread in Odessa and Ukraine, and landslides are also very important, and they are very dangerous. So that is why we have to uh, design building as far as it possible from such kind of construction sites, because landslides, to protect the building from the landslide, it costs an arm and a leg. It is very expensive solution, so that is why the most expensive buildings are located not far from the seaside, on the landslide territories, because not only because the sea view, but also because the construction of this building costs very big amount of money, because to protect, it is very important deal to protect the building from the landslide. And here is the another situation with the landslides. I will not stop on this situation. The main that you have to know that we have to protect this kind of territories from the impact of water, and there are certain retaining walls which can protect our landslide from the catastrophic locations. By the way, here is the solution of the Odessa situation, because in our cases, I told we have a combo of situation. We have a combo of abrasion and landslide, and our beaches are not only for the rest, but also they serve to protect our seashore or seaside from the impacts of water from here, or from the landslides from here. And these pictures will help us to define what kind of difficult ground condition can make this situation. For example, it can be caused by landslide, it can be caused by the sinkhole, it can be caused also by the subsiding soil, or even undermined territory which can be located under this corner. In this situation, we have a problem which with the emptiness which is located under this part of the ground, which leads to these kind of cracks. In this case, we have such a certain problem, which is caused by the location of something rigid under the central part of the building, because these parts of the building moves in the vertical direction, moves down in this direction. Next, the difficult ground condition that we will discuss today, it's called mm, seismic impacts or seismic hazardous territories, and we will consider only few moments which are connected with the earthquake. So first of all, you have to know that not all Earth is under the seismic impacts. Only 10% of territories is devoted to the seismic impacts, but more than 50% of the mankind lives on that 10%. And the main architectural monuments which called Seven Wonders of the World, all of them was under the seismic impacts, and half of them were destroyed by the earthquakes, and only one wonder still stands, and it gives us the best example of earthquake proof engineering. When we're talking about the Ukrainian local situation, we have a big amount of earthquakes, more than 30 earthquakes due the 900 period, and most dangerous earthquake takes part in the seismic regions of Crimea and the south western part of Ukraine. Here is the earthquakes of Odessa. In Odessa, we had as minimum two strong earthquake with intensity 7. And here is the map of seismic intensity, and here you can define that the most seismically dangerous areas are located in Crimea and in our Odessa region. Here is the peak ground acceleration, and you can see that most of them are located in Romania, but some of them located directly in the Crimea. And also, we have to consider the scheme of tectonic zoning of Ukraine, and you can see that Ukrainian shield, as it called, this seismic platform is consists of the small other shields, which with the quantity of more than 30. But here you can see the main crack between big tectonic plates, and this crack gives the most part of problems with the seismicity in Ukraine. By the way, we have 5 sources of seismic impacts in Ukraine, which are located in Crimea, in Carpathians, in Romanian Dobruja, in zone Vrancea, in Romania, and also we have a part in Ukrainian platform, as I told, in Crimea, in Donetsk, Lugansk, etc. Also, we will discuss that all buildings destroyed during the earthquake because of design, construction, operating, and other errors. Also, because of the errors in regulatory codes, in the building codes, and the complete disregard of seismic hazard. What can cause earthquake? First of all, it's tectonic action of tectonic plates and lithospheric plates. It's more than 95% of all cases. Rest of the causes are volcanic impacts, landslides, and technogenic. So it is the influence of mankind on the planet and its response to it. When we're considering tectonic impacts, we have to remember that our planet consists of various layers, and those layers creates uh, the situation where the most stiff layer is moving above the mantle, and the interaction of parts of the karst crusts for sort of this crust leads to the earthquakes on the surface of our planet. And if we will consider in details, here is our crust, and it consists of various layers which interacts one to each to other, and that interaction can be defined in those four main type. So it is a shift connection when it is moves like this. It's spreading when one part of tectonic plates move in this way direction from each other. Subduction when one plate moves under the other, and rifting. Same situation with the spreading, but spreading is the situation on the ocean. When we're talking about the ocean, and rifting on the surface. Another situation, it is the names of those interactions. It's map of lithospheric tectonic plates, and here we can see the mechanism of the earthquake. We have a hypocenter, and the focus of the earthquakes, hypocenter focus of the earthquake, and the epicenter, which is located above the epicenter, above the hypocenter. And there are three types of focus location. It is deep focus, shallow focus, and normal focus. With the deeps, normal is between 80 till 300 from 80 to 300 kilometers, and there are deep focus earthquakes with deep focus with the depths of more than 300 meters. Next. Next question which we will consider today, it is the seismic waves, and here you can see the movement of seismic waves. So first of all, it is, you can see the fastest wave called P wave. It's primary wave, and then secondary wave goes after it, S wave. So here you can see two volumetric waves, volume waves, two volume waves, and also we have two body waves and two surface waves called relay and lava wave, and all of them makes a certain impact on the building during the earthquake. By the way, how can we evaluate an earthquake? We have two kind of scales. So first is the Richter scale, and the second is the intensity scale. So those two types of scales gives an ability to assess the seismic impacts. What is the difference between them? Richter scale gives an ability to measure the energy of the earthquake when in the same moment it based on the displacement of the ground. But when we are talking about the intensity scale, it's more analytic visual scale. It's when we are looking to the when we are looking to the building, and according to the situation that we see, we define the amount of seismic effects, and it gives us an ability to assess the seismic effects. It's from 1 till 12. Grade have, by the way, Richter scale have not maximum limit. Here are the intensity scale. Here is the information about Ukrainian scale. It is called DS2 scale. There are certain types of buildings according to which we are measuring the effects of earthquake on each of those types of building. And most seismic resisting building is called A. F2. F2. It's building with such systems of regulation of seismic influences. And from the another point of view, we have A1. It is the worst case for the seismic buildings. It's made of bad non-quality masonry. Here is the ratio between those scales. So during one earthquake, one intensity, we can define one magnitude. We can see all 12 intensities at the same, for example, the same country or at the same continent. And next way, so first part was devoted to the seismic definition of the seismic impacts, and next part will be devoted to the seismic resistance. But this part of lecture we will consider next week. So, do you have any question?
Certainly.
So thank you. I will download this lecture to the YouTube and see you next week on the fifth pair. So at 14:40, I will wait for you. See you later. Goodbye.
Thank you. Have a nice day.